So make sure you put the date just in case we need it to refer to. So I have added that up there. We're going to do 6.2, use multiplication properties of exponents. So very similar to what we did earlier. It's just a little bit more, I don't know, detailed, or a little tweak on it. You'll see. So go ahead and write down that title. Okay. So the first thing, let's look at what a base is. You're going to need to know this for our assignment. So a base, these are 3 examples, okay? So we have 4 over 7 squared. Our 4 over 7, that's considered to be the base, okay? Then you have 0.9 squared. Our 0.9 is our base. And then 2 cubed. Our 2 would be the base. Whoop. Oh my goodness, I'm having problems. There we go. Just because there were so many little things I felt that needed to be done. But some of you might think it's super easy, so. I forgot to hit record. So again, our exponents are the 2 over here, and that 3. Record. Ooh, pooey. Okay. So again, the product rule of exponents, if we have xa plus or times xb, it would be xa plus b simplified because we're just adding those exponents. And the base, which is the x, will stay the same. I'll say this again. Okay. The power rule of exponents. So that was the product rule. This is the power rule. Okay. So if we have something like xa times this exponent b, right? So whatever it would be a number of some sort. When you have something that looks like this, you're going to keep your base the same, and then you're going to multiply the a and the b, the exponents. So product rule, which is funny, it's kind of reverse if you think about it. The product rule you're going to add, the power rule you're going to multiply. Let's see what's on here next. Okay, so now I wanted to put a couple of examples. Let's look at the first one. And I just put, you don't have to write this here unless you want to, but this one would be an example of the product rule. Okay, so if we have k to the 5th times k to the 4th, how's that going to look? So remember, a lot of you will probably get this one quick, but our k is the same, right? The same base. So it's going to stay k. And then we add the exponents. So it should be k to the 9th power.
Thank you.
Yep.
It would be h to the 7 raised to the 2nd power.
Raised.
Power.
Raised. Okay, thank you. Thank you. Okay, so guys, raised. I knew I was missing a word there. I just couldn't.
You can also just say h to the 7 to the 7th power.
Okay. All right. So this one's the power rule of exponents, right? So this one, ooh, I got cold all of a sudden. Okay, so this one, if you wanted to write it out like this, you could, because you're going to multiply those, right? The base is going to stay the same, so it would be h to the 49th power, or that's how I've always said it. Yeah. One, the power, sorry, I had another boo-boo there. I see my ugly whiteout. The power of a product rule of exponents. So the power of a product rule of exponents. If we have something like, we have 2 bases in there, right? So like we kind of have like an a, or we have 2, I don't know if that would be considered bases, but we have the 2 different variables that say a and b, right? But we want to multiply that or raise it to the power of n. So in order to do that, you're just going to take a to the power of n and then b to the power of n. So you're still multiplying those, but we have to multiply this n to everything in the parentheses. That make sense?
I kind of think about it as it's like it's outside the parentheses, so it has to kind of get like backwards distributed to the exponents.
Okay. Yeah.
because the A and the B actually have an exponent of a 1 on it.
Mm-hmm.
So you're multiplying the n times the 1 on the A, the n times the 1 on the B. Because sometimes they'll have numbers. There's probably an example like that.
Yeah, I think mine might, but yeah, so basically, yeah, it is just distributing.
I mean, that's just kind of the way I think about it. That's not, you won't see that language probably like in a math book.
Right.
I kind of think of it as like backwards distributing of the exponents.
Okay. All right, are we ready for our example? Okay, let's look at this guy. Oh, I had two, sorry. Let's look at this one. So, negative 6q times, I guess, am I saying 5 or raised to the 5? See, I don't know how to say them right on these. I know I'm saying them wrong.
Yeah, it's to the 5th power.
To the 5th power, okay.
That 5 is an exponent.
Okay, so negative 6q to the 5th power.
Make sure you're writing that 5 as an exponent, everybody.
Yes, that is. It is
at the top.
It's a little big. Sorry, that is my exponent. Yes, sorry. It didn't look big when I wrote it, but now it does look quite amplified. Aww, how cute! I love little baby puppies. Okay, so does that one make sense? So we're just doing the reverse distribution. So if we rewrote it with the parentheses, we're going to distribute like that, right? But then we obviously don't need the parentheses in the answer, so we just take them out, put it all together, and that's the best we can do. We can't solve it anymore. We simplified it.
Actually, on that one, I think what they're going to want us to do is when it's a number raised to a power,
they do.
They're going to want it to multiply that out. So you're going to do negative 6 times negative 6 times negative 6.
I wasn't sure what the negative 6. Is there an easier way to do that on our phones? Because I can't figure out how to do it on mine.
If you have to use a scientific calculator. So like if you have an iPhone, if you take your regular calculator and hold it sideways.
Yes, that's okay. So then I hit
then 6 and
negative.
then the x raised to the y power button.
X raised
and then 5.
Okay, I'm looking. X, they're so small. Oh, there it is. I see it. Okay, and then 5. Awesome. Thank you. I couldn't figure out how to do it on my phone. So yes, Anise.
I usually don't even consider the negative on the calculator. I just do the number part.
Mm-hmm.
And then go and think about, is it going to be negative or positive?
Oh, okay. I just added in the negative. It worked easy, but okay. So if we did that, guys, we're going to get, like Anise said, we're going to get negative 7,776. And then q to the 5th. Okay. All right. I guess I should. Yeah. Ay. I'll get the lingo. It's been a long time. Okay. Oh, I think I have another one back here. Oh, I lied. I have one more example because it had a lovely fraction in it, so I thought I'd do that one with you. That should be fun. Of course not. Why would I? Okay. So now we can look at this 6 squared, and we say 6 times 6, right? Because that's telling us to multiply it by itself twice. So, 6 times 6 is 36. Then this is an S, so we can't really do anything with that, guys. So we're just going to say S squared. That looks like a 5. I apologize. I got to remember not to use S's anymore. Okay. Then we have 2 to the 8th power. And if I did that right, I got 256. 2 raised to the 8th. Yes. So 256. Sorry about my dogs. They hear a siren and they're howling. I apologize. And then we can do S, 4 times 8, right? And that would be 32. So that's where we're at. Any questions thus far? And they won't shut up because they just hear the siren, so I apologize, guys. They'll shut up in like 30 seconds. All right. Now, now we can do, we can see that we have this base and this base. They're kind of like a like term, right? They don't have anything attached to it, it's just a number, right? So we can...
Like we would call those the coefficients.
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 I'm going to write it for you.
The number part in front of the variable.
Okay. Coefficients. Okay. So we can multiply those together. And what do you guys get? I know what I got, but let's see if you guys get the same as me. Someone tell me. 36 times 200. Oop. My phone is dying too. I think my screen's pooey. I can't type. There we go. Yes. Yes, that's what I got on these. Thank you. So I'm going to put it down here. So we're going to write 9,216. Then we can now deal with our S's over there. So we're going to add these ones, right? If there was one outside here, we'd multiply it, but we're going to add these two up. So we're going to get S to the 34th power. So that should be what we will put in. Looking. So 2 over 5 q squared times u to the 9th, and then all that raised to the 4th power. That's a lot. And remember, our first step is just going to be to distribute that 4 throughout there. And remember, when we have this, we are going to multiply the 2 and the 4. So our first step, I mean, you can write the answer if you want, but I'm going to write it out as 2 times 4 so you see it. And the same with the u. So that's where we're at so far. Let me know if you have any questions. I didn't look at my notes first when I asked you. I did actually do that. So, okay, so then if we're doing that, guys, then this one's going to look like 2 times 2 times 2 times 2, right? Which gives us, if I did it right, should get 16, right? Is that what you guys got? Then, if we're going to do the 5, we're going to do that 4 times. And that should have got us 625. If you get something different, let me know. Just make sure I'm doing my math right. So that would be the first part of it. Okay. I'm going to rewrite it here because I like it nice and clean for my answer. Then we have our q, and remember we multiply them, right? So we're going to have q to the 8th, and then we have our u to the 36. Okay. Does that make sense? Everyone good there?